This is our last video on an overview of mechanics. And what we're going to do in this video is go through what has been called the big picture. And we owe a debt of gratitude to the YouTube videos right here. Lasavirin 1 down here in the lower left corner of the screen. Much of what is going into these videos has its foundations in what we find on these videos, including this entire picture right here. And basically, this picture is to help us realize that if we know this quantity about the physical situation, then we could calculate maybe this quantity or that other quantity. This is kind of a big map of mechanics and how it all works together. So if we start right here with velocity, velocity is related to position. And how is it related? Well, the change in position is the time integral of velocity. If we have the position, we can differentiate it with respect to time and get velocity. That's pretty neat. What about if we have velocity and we take the time derivative of that? Won't it give us the acceleration? I don't have enough space to write the whole word there. There's acceleration right there. Similarly, if you have the acceleration, you can integrate it with respect to time, and you can get the change in velocity. That's pretty neat. Let's keep going to the right here. If you know the acceleration, and let's say you know the mass of the object, then you could find the net force by Newton's second law. If you know the force on an object, and you know how much time elapses in terms of the force acting, you can get another quantity, which we haven't run into yet, but we will. It's called the impulse, and it's symbolized with a J. So that's what goes up here in that box. So we're introducing some terms that we haven't run into yet, but we just want to have the map of all of these out there so that when we study them in detail, we can always go back to the map and we can say, oh yeah, that is how that connects with that other thing. One thing you should have learned in first year physics with regard to velocity is if you know the mass of the object and you know its velocity, you can calculate momentum. And it turns out, you might have learned this in your first year class, that the change in momentum is equal to the impulse by what's called the impulse momentum theorem. Earlier in this video series, we have gone through that the net force is equal to the time derivative of momentum. So that connects those two islands. What about down here? We've got 3 more islands to go. If we know velocity, we can find kinetic energy. And what's the equation for that? Well, obviously that's going to be K is equal to 1/2 mv squared. That one we know, don't we? If you take the time derivative of energy, you can get power. The change in energy per time is power. Might not necessarily be entirely all kinetic energy, but the time derivative of the energy is going to give you the power. In your first year physics class, you might have gone through this idea that the net work done on an object is equal to its change in kinetic energy. So if you have some information about the kinetic energy, you can often find the work that's been done. What about here? How do force and work relate to each other? Again, this is an equation that we're going to study in more detail in the next unit, but basically work is force times distance. So there's an equation that connects that. And finally, power is equal to the amount of work done divided by the time. So what this diagram is showing maybe I can get all this on one screen, at least for a short time here. There you go. We have Lassevere in 1 to thank for this big picture. It's a pretty handy diagram when you're given something in a physics problem and you're asked to calculate something else and you think, how can I get from here to there? You might want to refer back to the big picture.